Hi guys, this is a video for 6162. We're going to start talking about polynomials and operations with polynomials. So first, let's define what that is. So a polynomial, poly means many, and nomial comes from the word meaning term. So we already have defined terms in mathematics as being factors attached through multiplication, okay? So they're separated by addition and subtraction. So we call one term a monomial. And a polynomial just means many of those. So we're adding and subtracting multiple monomials, okay? So what is a monomial? Again, the exponent must be whole numbers, 0, 1, 2, 3. There are no variables in the denominators or the exponents. And there's no roots or absolute values of variables. So some examples might be something like 3x plus 1. So I have variables, okay? The exponent on this variable would be 1. I could actually think about this having the variable x to the 0, okay? So that is a whole number, that's fine. I can have fractions, but the variable just can't be in the denominator. So I could have something like this. That is also considered a monomial. This one would be a polynomial because this one has two terms, okay? This addition separates the 3x from the 1. And we know we can't combine those because they're not like terms. So this is a polynomial, this is a monomial, okay? So non-examples are things that fail these, okay? So for example, if I have 1 over x, so I have a variable in the denominator, that is not a polynomial, okay? Or a monomial. Absolute value of 3x, I don't know why I did double bar there, sorry you guys. Absolute value of 3x, okay, so I cannot have absolute value of that. Or the radical, where I have variables underneath. None of those are examples of a monomial, okay? All right, so when we're looking at monomials or polynomials, we have ways to classify them. So one of the ways we classify them is by what's called their degree, which is just looking at it and seeing what is the highest exponent listed. So it's helpful to put it in what we call standard form, where I just go in order from greatest to least in terms of the exponents. So this is an example of a polynomial. It's in standard form because it goes from the highest exponent of 3 down to 2, down to 1, down to 0. So the degree is the highest exponent. So this is a third degree. And the leading coefficient is the number in that term that has the highest exponent. So in this case, it would be a 5. Okay, I've already filled in kind of the vocabulary here, you guys, but we have specific names for the polynomials depending on how many terms it has as well. So monomial is just one term. So for example, 3x, okay? A binomial has two terms, okay? Trinomial has 3 terms. And a polynomial is anything that has 4 or more. So that example from up above, 5x cubed plus 8x squared plus 3x minus 17 would be an example of a polynomial, okay? But anything under 4 terms, we have specific names that give us more clarification as to how many terms it has. We also can classify it by its degree. So if it's constant, it's just going to be a whole number, something like 7. If it's linear, okay, then it has something to the first degree, okay, something like that. A quadratic is something where I have x squared involved, okay, and again, I don't have to have everything in between, but just the highest exponent is a 2. A cubic, something to the third degree, okay. Quartic, something to the 4th degree, so let's do 3x to the 4th minus 8x squared plus 4. Okay, quintic, something to the 5th degree, and 6th degree, 7th degree, 8th degree, 9th degree. Once we hit 6, we just use the number to describe the degree, and it can be anything beyond that. So let's just do, we'll do the 7th. So this would be to the 7th. This would be a 7th degree monomial. Okay. So now we're going to classify These examples, we're going to basically use both of these as a word bank. So we're going to pick one term from this and one term from this. So we're going to classify both by degree and number of terms. So typically we'll actually say the degree first. So it's helpful to put it in standard form if it's not. So I'm going to do standard form. So my highest exponent is 5. So I'm going to list that term first. The next highest exponent is 3. That's a positive 2x to the third. And the lowest exponent is a 1 on that x. So this is now in standard form. So my leading coefficient is my degree is a 5. So fifth degree is a quintic. So we would call this a quintic. And then there are 1, 2, 3 terms. So that is a trinomial. Okay, in this one, put it in standard form. So negative 3x to the fourth minus 2x cubed plus 2x squared plus 5. So standard form. Highest exponent is a 4, so this is a quartic. Quartic, and it has 1, 2, 3, 4 terms, so it is a polynomial. This one's in standard form, so this is a 6th degree. And there's only 2 terms, so this is a 6th degree binomial. All right, and that is how we classify, so by degree and by number of terms. Okay, next we're going to look at operations with polynomials. So when we are subtracting polynomials, we've actually done some of this with just algebraic operations, you guys, but we have maybe more terms this time. Anytime there is a subtraction sign, we want to treat that as a -1 multiplying everything in that second set. So we need to distribute before combining like terms. Okay, so we have 2x squared plus 3x from the first polynomial, and then minus 1x minus -4 becomes +4 minus 3x squared. Now combine like terms. So I'm going to start with the highest exponent, so I'm just putting it in standard form already. 2x squared minus 3x squared is a -x squared. 3x minus x is positive 2x. And then plus 4, now that's in standard form. Okay? Okay, multiplication, we're going to distribute. So I have x times x squared. Remember, when we're multiplying things that have the same base, we can add their exponents. So x times x squared is x to the third. X times -3x is -3x squared. X times -1, -1x. Now I do take the -2 and multiply by everything. So -2x squared plus 6x plus 2. Now I combine like terms. So my highest exponent is x to the third, so I'm going to keep that one here. Then x squared, so -3x, -2x squared is -5x squared. And then -x and positive 6x is positive 5x. And then that plus 2 is solo. Okay, here we're multiplying a trinomial times a trinomial. I still distribute. This time I'm just going to do it 3 times. Okay, so I'm going to take x squared times everything, then 2x times everything, then 3 times everything. So x squared times 2x squared, add the exponents, and I get 2x to the fourth. X squared times -4x, -4x cubed. X squared times 1. Now I'm on to the 2x, so 2x times 2x squared is 4x cubed. 2x times -4x, -8x squared. 2x times 1 is 2x. Now 3 times everything is 6x squared minus 12x plus 3. Now combine like terms, so look for the highest exponent. It looks like mine is a 4, so 2x to the fourth. X to the third, here I have -4 and positive 4, so those are opposites. Those are just going to cancel. Now x squareds, I have 1 minus 8, so I'm at -7, plus 6 is -1. So -x squared. All right, now I have 2x minus 12x is negative 10x, and then plus 3. All right, so x plus 3 cubed, remember if it's addition or subtraction here, this I cannot distribute or apply that exponent of 3 to everything in between. This really means x plus 3 times itself 3 times. So I'm going to do 2 at a time. I'm going to start here with just these first two. So x times x is x squared. X times 3 times x, and 3 times 3 is 9. So I took care of these two to get this. Okay, combine some like terms. So now I have x squared plus 6x plus 9. Now I still need to multiply this one. So I'm actually going to do this one first. So now I'm going to distribute the x times everything and then the 3 times everything. So x times everything is going to give us x third plus 6x squared plus 9x. 3 times everything is 3x squared plus 18x plus 27. Combining like terms and putting in standard form, I get x to the third. 6x squared plus 3x squared is 9x squared. 9x plus 18x is 27x, and then 27. All right, last part of the video today, you guys. So this obviously I could get really crazy and start taking things to the 4th power, the 5th power, the 6th power. And obviously I can write those all out, I can distribute, but it's super time consuming. So we have this pretty cool thing called a binomial expansion. Where Pascal's triangle has basically uncovered a pattern. So here's an example. So in row 0, if I take a plus b to the 0, it's 1. And we know that because anything to the 0 power is 1. If I do a plus b to the 1st power, anything to the 1st power is just itself. A plus b to the 2nd power, this is the expansion that I get, then to the 3rd, then to the 4th. So Pascal's triangle went through and picked out some interesting patterns. The coefficients on those numbers are 1, 1, 1, 2, 1, 1, 3, 3, 1, 1, 4, 6, 4, 1, and on. And so these are the coefficients on those terms. The other part of the pattern, you'll notice, is whatever the exponent is, that's the exponent on the first term and the last term. And then in the middle, they go down by 1 or up by 1. So A is going down by 1 and B is going up by 1. Okay, here's kind of the rules describing that down here. We're going to try and show that here using this as our example. So y minus 3 to the 4th. So if I think about that as a plus b, I can think about it as y plus negative 3 to the 4th. So in this case, a would be the y and b would be negative 3. Okay, so we're taking it to the 4th power. So that means we're using row 4. Okay, and so these are the coefficients I'm going to have. 1, 4, 6, 4, 1. Okay, so now what happens is I have 1 times y, this is the a, to the 4th power. So whatever that exponent is, that's what's going to be on the 4th. Now, my y's are going to go down by 1, and my negative 3's are going to go up by 1. So right now it's negative 3 to the 0. Okay, now I'm going to go up by 1. So I'm going to have the 4 in there. Okay, so I'm going to now have y to the 3rd. Okay, and negative 3 to the 1st. So here's the A, and B. Okay, so I'm following this one, A, B, and I have that 4 in front. Okay, so now I'm going to continue. So now I have 6 y squared this time, so the y's are going down by 1 in the exponent. The negative 3 is going to go up by 1. And of course I'm going to run out of space. Okay, then I have 4, so now I have plus 4, y is going down by 1, so now it's to the 1st. Negative 3 is going up by 1, so now it's to the 3rd. Okay, and sorry, I'll just write that one down here. So we have plus 4y, negative 3 to the 3rd. now it's easier to see. Okay, and then the last one is 1, and it's just b to whatever the highest exponent was, which is 4, and our b is negative 3. Okay, so now if I come through and simplify this, y to the 4th, okay, negative 3 to the 1st is negative 3, times 4 is negative 12. Here, negative 3 squared is 9, 9 times 6 is 54. Here, negative 3 to the 3rd is negative 27, and then I'm going to do negative 27 times 4, which is negative 108. And then lastly, negative 3 to the 4th, I believe, is 81. So we have a positive 81 there. So this would be y minus 3 to the 4th power. So y minus 3 times itself 4 times equals this. So it's kind of a funky thing, but it's definitely shorter than writing out y minus 3 times y minus 3 times y minus 3 and distributing it 4 times. So this is just a nice trick when our exponents get to be, honestly, anything 3 or higher. This is more efficient. So let's try one where my exponent is 3. So we're going to use row 3, okay? So here's my coefficients, 1, 3, 3, 1. Okay, so in this case, my a is 3x and my b is 1. So I start out with a to the exponent I'm given. So 1a, which is just 1, and then 3x to the 3rd, okay? b to the 0. So 1 to the 0 is just 1. Okay, now I'm on to, sorry, I'm going to scoot this over, you guys, so I have a little more room. So we have 1 times 3x to the 3rd times 1 to the 0. Okay, now my a is going to go down by 1 in exponents, and my b is going up by 1. So this time now my coefficient is 3. Okay, 3x squared, and then times 1 to the 1st, which is just 1. Okay, then coefficient of 3 again, 3x now to the 1st power, and then times 1 to the 2nd power, okay? And then our last one, 3x, the a is going down by 1, so it's going to be 3x to the 0, so that one's gone. My coefficient's just 1, and then times 1 now to the 3rd power. Okay, come through and simplify. Now, remember, 3x to the 3rd does mean 3 to the 3rd times x to the 3rd. So this is going to become 27x to the 3rd. Here, I have 3x squared, so that's going to be 9x squared, times 3 is 27x squared. And then the times 1 doesn't change anything, right? 3 times 3x is 9x. 1 squared is just 1, so 9x times 1 is 9x. And then 1 times 1 to the 3rd, 1 to the 3rd is still 1, times 1, still 1. Okay, so again, probably a little quicker than what we did up here, where we had to expand it 3 different times. Here, using the binomial expansion and Pascal's triangles, we could accomplish the same thing.